Hi everyone, thank you for joining us today at a webinar. We're going to wait a couple of minutes for everyone to join us. Thank you for your patience. So we're about to start this webinar. Thank you again for joining us today. So today's webinar is about AI-driven alert triage and RCA, where we are going to share with you some live production scenarios. But first, before starting, we wanted to share that unfortunately, Greg won't be able to join us today, but we have here Seth, and the webinar is going as planned. So as mentioned, today's speaker is Seth King, our customer success engineer here at Logz.io. Seth, the floor is yours. Good luck.
Awesome. Good afternoon, everyone, and welcome to today's webinar on AI-driven alert triage and root cause analysis. I'm Seth King, a customer success engineer at Logz.io. Really excited to show you how we're transforming how engineering teams are handling production alerts. As far as our agenda for today, we're just going to do a short overview of Logz.io. I'll discuss my experience working with customers. Then we'll walk through how we would have handled this alert manually if we didn't have AI, just to give you a sense of some of the typical steps and pain points that come with traditional triage. From there, we'll show you how AI handles the same investigation, and then we'll look to see how we can use the visualizations that the AI creates to save in a dashboard, as well as wrap up with Q&A. So feel free to note down any questions you have along the way, and we'll look to cover those at the end. So for those who are unfamiliar with Logz.io, Logz.io is an AI-powered observability platform that helps you monitor and troubleshoot your issues to accelerate root cause analysis and get better visibility across your systems. Here at Logz.io, I work with engineering teams every day, and I constantly see engineers stuck spending time investigating alerts instead of building features and contributing to their organization in other ways. The average team gets dozens of alert notifications every week, but only a small percentage of these actually require human intervention. The main issue is that it's difficult to know which alerts are worth investigating. So it requires a lot of time for engineering teams to triage these issues, and they still even miss some of the critical ones. The fundamental problem with this is just that humans weren't built to scan thousands of logs across multiple systems in real time. But thankfully, that's where AI is able to step in and help. So I'll show you how AI can investigate the situation in seconds, as well as correlate the data and tell you what's wrong, as well as what to do about it. We'll start today with a real alert. I'll walk through it manually. That way you can see how you would normally investigate it. Then we're going to have the AI handle the exact same alert, and you'll see it surface things I might have missed, as well as get to the root cause a lot faster than I would have. Um, excuse me. After that, I'll show you how to turn these AI insights into better playbooks that the AI to leverage. And of course, at the end, we will answer some of your questions. So if you do have any questions that we aren't able to get to, I'll make sure to email you once the webinar is over. So before we dive into the demo, I'm curious to hear about what everyone's experience is with alert management. So we'll do a quick poll. And while you're answering, feel free to drop any specific pain points that you might have with alerting in our chat. I'll try to address some of those with our demo, and the ones that I can't, I will make sure to follow up afterwards. Awesome. So thank you everyone for answering our poll question. As I mentioned, if we're not able to answer your question directly on this webinar, I'll make sure to follow up once the webinar is over. But we're going to start our webinar with looking at an alert that I've configured as well as investigating it manually. So I'll share my screen here and we'll show you how we configured that alert as well as a little bit about the platform. Addie, are you able to see my screen?
Yes, we can see it. Thank you.
Awesome. So here we're looking at the Explore page of our logging portion of the platform. And if we wanted to configure an alert, we would do so in the alert section. I have previously set up an alert to look into error 14 issues. And in the fifth section of the alert, this is where AI analysis is enabled with this checkbox. The alert can be sent to, or the analysis can be sent to Slack or Microsoft Teams. And very soon we're going to have a webhook integration where you'll be able to send this to any platform that can accept a webhook. Now, it looks like my alert fired as I got a notification over Slack about the alert being triggered. And here we can see what the alert will look like if there wasn't AI analysis, which is underneath it. And if we wanted to manually investigate this alert, what we would need to do is click this View in Logs button to look to see the logs that met this condition and start to see what it was that triggered this alert. Here it looks like we have an alert that is affecting our front end as the Kate's container name is the front end, which is our service. And excuse me, if we were to scroll down to the message field, it looks like it's indicating a gRPC error 14 unavailable message, which typically means the service can't establish a connection and points to network issues or failing downstream services. So let's walk through how we're going to investigate this from here. I'm going to be curious to know how widespread and persistent this issue is. And to do this, we're going to want to query all similar gRPC unavailable errors in the front end. And I can do this with a Lucene query. First by selecting the front end container name, which is the front end. And we will also look for the key for the string unavailable in the message field. Awesome. And we will extend the time range for this to be over the last 3 hours. And it looks like there's about 1,400 logs that meet this criteria. And this volume of errors tells us that this is something we need to prioritize. It wasn't just one or two errors or a transient issue, but it's something that requires deeper investigation. So from here, our goal is going to be identify which downstream services the front end can't reach, and then whether that failure is impacting other parts of our technology stack. So if we want to see if there are other services affected, we can simply do a query here where we will search for message field unavailable and we will look at anything that's not the front end container. Container, front end. Cool. We will now run this search. And when we run this search, we can see that there are no other services reporting these errors, which gives us a strong indication that the issue is specific to the front end, or maybe it's just a connection to a single downstream dependency. So while this error is pretty serious, it doesn't look like it's affecting any other of our containers or services. So the next thing I'm going to want to do is I'm going to want to take a look at our infrastructure. And to do this, we're going to want to see what node the front end service is running on. And we can see here it's this 10-1-9-81. So if I go to Kubernetes, and I now go to our nodes. We can look for this specific node. I believe it was on the K18's demo cluster. And here we can actually see the node that the front end pod is running on. Um, It looks like things are okay here on this pod, which rules out to me any system instability issues as the cause. And it does point us back to there being an issue with connectivity or service to service communication. The last thing we're going to really be able to do here is we're going to look for errors in other services that the front end depends on. Maybe another service went down, maybe the card service or recommendation service, and that would explain our gRPC issues. So to do this, we will search on a couple containers and look for errors in those logs. So I will do K8's container name. We'll look at the cart service. And we'll also take a look at the recommendation service. And we will want to know, is there any errors happening at the log level field? So we can perform this search. And again, this query returns no results. So the dependencies seem pretty healthy. So just to review what we've done so far, we've seen that there's an issue in the front end, which is isolated. The error is consistent, it's happening multiple times, and the infrastructure looks pretty good. And our other dependent services don't have any obvious issues. So I have a strong suspicion this is a networking or connectivity issue, but we also haven't found the root cause, which is good because now we can actually look at the AI agent analysis and we can start to see what it did, and see if it can help us get to the root cause faster. So here we can see the analysis or the conclusion that the AI agent came to. But before we look at the conclusion, we can actually pull up the agent and go to the chat history, and we can take a look at what analysis it did into the issue. So now that the agent has actually ran its analysis, we can follow its step-by-step thought process here, so that we can confirm that the conclusion it came to is correct, and we can also compare it to our manual investigation that we just did. So for step one, we can see that it wants to look at more logs, rather than just the ones that triggered the alert, which is what we did. And it will get this sample of the logs. We can open up a preview actually to see what this returned. We can see it saw a lot more logs, which is similar to what we had seen earlier. It looks like next it wanted to see if there were a consistent pattern of these errors, and we can take a look to see what that looks like. And yes, this pattern was consistent, so it looks like it just got some more information to confirm that this was a widespread issue. Next, it's going to actually see if this issue is affecting other services, which is what we had done as well. And I would expect that there were some logs returned here. Oh, actually, this was looking at the front end service, excuse me. But it looks like it was looking for other errors, not just the error 14 unavailable one, to see if some of those errors were impacting this main issue. And based on the analysis that it did here, we can see its overall conclusion, which is that the front end is experiencing this issue. It's occurring when handling requests to specifically the recommendations endpoint, which is not what we were able to uncover manually. It also is telling us that it's affecting multiple pods, which is throwing a 500, and that the issue is happening across different product ideas. The root cause here appears to be what we initially suspected, um, but it looks like it was able to go a little bit deeper to uncover what other services were impacted. And what's important to remember here is that the AI agent's analysis was pretty similar to the one that we had done manually, but it did this a lot faster. And it was actually able to give us some recommendations as far as what we could do, which is not something that we had been able to uncover ourselves earlier. So now we can actually take this one step further and we can ask some additional questions of the agent to learn more about the work that it did. So I can ask it, what other services does the front end depend on? As this wasn't something that I would know without doing some additional manual investigation. So we'll see what it comes back with. And it will work in this step-by-step reasoning process that we had seen earlier. That way we can follow its thought process and also have confidence in the results that it provides. So one thing that I also want to mention about the AI agent here when you are using it to analyze your data is it doesn't do a set amount of steps. It's non-deterministic in the sense that it'll perform as many steps as it needs in order to get to the root cause of the issue you're investigating. So it looks like in this case here, it's trying some additional queries in order to get more information. So while this particular question requires 5 steps, if you ask other questions, you'll see various different amounts of steps. But we can see here that it told us it's dependent on these 4 services. And one thing that I also think is interesting is it didn't just give us a flat list. It actually told us and gave us context on what's the role of each service, which helps us understand why is the front end reliant on these services. And critically, it's also mentioning here that, or as it had done earlier, was that the recommendation service is the one that was having issues, which is going to become a good lead for us if we were to immediately start to continue the investigation. A follow-up question I would have from here is to ask it, which service is most impacted by the front end 14 unavailable error, just to get some more insights into what it saw as an issue in the recommendation service as related to this error 14 unavailable. So hopefully we can start to see a little bit about how we can use the agent to proactively run an analysis on the triggered alert. But then we can also use it to continue the conversation and continue the investigation into the issue by asking additional questions of the agent. Um, and also want to mention that these conversations are stored in the chat history icon. So if you ever need to go back and review the work that the agent has done on your alerts, you can go to the chat history and take a look at it. You can also use these search queries that the agent runs to turn into alerts. And the visualizations that it produces we can also use those visualizations to be saved into dashboards, which I can show shortly. Awesome. So it's telling us that the recommendation service was impacted by this issue. And it was able to see this by looking at the crashback loop, as well as the high restart count that is happening in that service. And that's not even something we had been able to uncover in our manual investigation. Um, So it turns out that the front end errors weren't necessarily caused by itself, but by the instability in some of its other dependencies. And it caught that while I wasn't able to in even more time. So now let's just close the loop. Let's update the alert by giving it some more specific information. So next time this alert runs, it has better context on what we want it to do. So this looks pretty good, but I will also tell it here that if the recommendation service is having issues, check if the pod are killed, entering crashback loop. Awesome. So this will just give it a little bit more information of what we want it to do if the recommendation service is impacted in the future. And then once this alert fires, or next time it fires, it will have a little bit more context of what it should do immediately. Awesome. So we started with the manual investigation into this issue. It was pretty slow, but we did get the information we needed. Then we took a look to see how the AI would reproduce this logic automatically, and it actually discovered the true root cause. And then afterwards, we were able to update our alert, give it a little bit more context so it's smarter next time it runs. And this is generally how Logz.io just brings intelligence into observability and your incident workflow, helping you move from what happened to here's what to do next faster than ever. So with this, wanted to move into the Q&A section. Addie, you still there?
Yeah, I'm right here. Just a second.
Awesome. Cool. So like we said, we wanted to leave some time for people to ask questions. Feel free to scan this QR code and submit your questions. Um, Give everyone like 30 seconds or so, just to start to put some questions in there, and then we'll respond to them.
Yes, so the QR code is actually for schedule and demo with us. So feel free while we're talking about your questions to scan this QR code. So Seth, while you spoke, thank you for that, by the way. I've collected several questions from the audience. So thank you everyone for sharing that with us. I'm going to read the first questions and then you can take it from there. So the first question it will be, how customizable is the AI agent's behavior or scope of analysis?
Yeah, that's a great question. So if you wanted to customize its behavior when responding to an alert, I would recommend giving some thought into the description field, as this is how the agent is going to, or this is some additional context you can give the agent when responding to the alert. So the more specifics you can provide here, the better it can give you a response that's helpful.
Thank you. So the second question is, does the agent analyze logs, metrics, and traces out of the box, or do I need to configure data sources first?
So the AI agent currently is able to look at your logs and your Kubernetes metrics, but we'll also be expanding the amount of data it can use for its analysis. Obviously, that data needs to be in the platform for it to have access to do the analysis. So if you would want it to look into Kubernetes metrics or other metrics, for example, obviously that data would need to be in the platform and accessible.
Thank you. So what happens if the agent can't find a clear root cause?
Yeah, great question. So I think we saw that a little bit when I had asked it a question around one of our follow-ups. Um, it will it will take as many steps as it needs in order to get more information to get to the root cause. So it isn't working in a fixed number of steps, if that was what the question is alluding to. But I think in the same way that a human sometimes requires additional instructions and prompting to get a better answer, the AI agent works in a similar way. So if the agent can't immediately get to the root cause, it can at least get you started faster in investigating it. And then with additional prompts, could hopefully lead you to the root cause that you're searching for.
Thank you, Seth. So, what's the easiest way for someone to try the AI agent today?
Yeah, so as far as getting started with the AI agent on alerts, that would be as simple as configuring or selecting this checkbox here and then configuring an endpoint for Slack or Microsoft Teams. But if you're just more generally curious about how you can use the AI agent to start to chat with your data, you can go to the top right of the platform and select this icon, or you can click the AI agent button here. And then this is where you can start to chat with your data and begin to utilize the agent.
If you share your screen, we didn't see it.
Oh, okay. Let me try that one more
We don't
time.
want to interrupt you.
Are you able to see my screen now?
Not yet.
Okay. We try one last time.
Mhm. Now we can see it.
Awesome. So if you wanted to get started by enabling AI analysis on a particular alert, you can go to that specific alert. And then in the fifth section of the form, you can select this checkbox. Um, and then you can configure an endpoint in Slack or Microsoft Teams to send that analysis to. But if you're just more generally curious about how to use the agent to chat with your data and get insights, you can click the AI agent button here, or you can click this icon here. Both will open up the agent.
Amazing. Thank you, Seth. So we don't have enough time for sharing more of your questions, but as Seth mentioned earlier, we're going to answer you by email. Thank you, Seth. You can continue.
No problem. Yeah. So before we part ways, we just want to say to keep an eye out for our next webinar that's coming soon on our new Open 360 platform, and how we're continuing to push observability. So we're excited to unveil Open 360. It is going to allow you to create dashboards regardless of your telemetry data and have those customized so you can have logging metrics and alerts, logging metrics and traces in one dashboard. You'll also be able to investigate your alerts within those panels, as well as have the AI build different types of visualizations in your dashboard and analyze those dashboards. So Open 360 is going to bring a lot of improvements in the way that we handle alerts, as well as the way that you visualize and use AI to investigate your data. So thank you all for taking some time to join us today. And if you'd like to actually try Open 360 in your own environment, or learn more about what we're doing, we definitely encourage you to reach out to us and scan the QR code that we had just mentioned. So whether you want to connect alerts, test RCAs on your own data, or just want some more information on how our AI agent works, it's all there. And we look forward to chatting with everyone.
Thank you so much, Seth, for such an interesting webinar. Thank you everyone for joining us today. We hope to see you at our next webinar about Open 360 on September. Thank you and enjoy your rest of the day. Bye bye.